Hi, welcome to our math. Today I'm doing a series of videos on exponents, exponent rules, and simplifying expressions. I have 5 examples on this video. It is because I want to introduce what a negative exponent is. Now, if you want to think of an exponent as being multiplication, and you multiply forward every step of the way, you could kind of think as a negative exponent as dividing. Now, when the negative exponent is in the numerator, if you're suddenly dividing, it makes sense that it goes to the denominator. But you have to remember, if it's in the denominator, it jumps to the numerator. As strange as this sounds, when you have minus a negative, it's plus a positive. Well, dividing division is the same as multiplying. It's still that 2 negatives making a positive. Not that division's the negative, but it is the one that whittles away versus multiplication that tends to grow. So, first of all, when a negative is attached to parentheses, remember, if a negative means division, when you divide by a fraction, you flip and multiply. So when a negative exponent is attached to parentheses, you find the reciprocal of whatever is in the parentheses. So all I have to do for this to make this a positive is turn this into 7/4. For my second example, notice the x has the -8, the 3 doesn't have a negative exponent. It's going to stay right where it is. This is going to become 3x to the +8. You can put it over 1, but once you don't have anything but 1 in the denominator, you don't actually need to write it. For this next example, the x has a negative exponent, the y does not. So we're going to separate these guys. We're going to keep the y in the numerator, y cubed, and move the x to the denominator, x to the 6th. You can think of a negative exponent, if you don't want to think of it as division, as like a light switch or a switch in general, switching bases from numerator to denominator. Once you've done the switch, the negative has done its job, and you can move on. It doesn't need to be negative anymore. Another way of thinking about it, I'm giving you lots of analogies. One way I like to think about it is I like to think about it as a battle, North versus South. I really don't know much about battles and war. I was brought up hippie, but I do know that there are double agents, and you can think of a negative exponent, North versus South. That x is, all those x's are double agents who the South thinks are working for them, but this is really a double agent working for the North, and so if everyone was going to be honest, that x to the 8 would go up top. I do have to realize that this is division, and with a 35 and a 14, I need to reduce, so I'm also going to divide by 7/7, and I'm going to get 5x to the 8, so 35 divided by 7 is 5. My double agent moves up to the north and is now a force for good. 14 divided by 7 is 2, and the y stays in the denominator because the y has always worked for the South. Oftentimes I see students do this and they put everything in the North, and just if you think of it as a battle, you cannot take a Southern soldier and say, hey, you now support the North. It doesn't work that way. So in this example, this is like my first example. This a belongs in the denominator, this b belongs in the numerator, and I should have b to the 11th over a to the 7th. So once again, a negative exponent, if a positive exponent means multiplication, a negative exponent means division, and it acts like a switch, switching a base between the numerator and denominator. Once it's done its job and switched it, the exponent stays the same in value, but becomes positive. All right, I hope you've liked this video. Subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.